Okay, just want to take a quick peek at the data sheet with you. I really want you guys to read through this on your own and kind of see it. But this is what I went through in the field. So you're first conducting your variable radius cruise for your center point, measuring the diameter of each tree, and then looking for nest trees. And nest trees have a crown that makes up a fairly good proportion of the height of the tree, and they're at least 14 inches dBH. May have nests on the south side of the tree. They find that the squirrels like that warm south side the best. Then calculate the basal area for your plot, tally the number of trees in each diameter class for each plot on your data sheet, and we'll go through and do that today. Determine the trees per acre. Okay, got that, and put that on Form 1 as well. Determine percent canopy from your plot. In the field, I did it every 5 feet. The data sheet says every 4 feet. You get the idea. We did that for about 60 feet or 18 meters. Record that on Form 2. Do it 3 times or 4 times. At the end of each transect, then you go through and you figure out how many trees have that interlocking canopy. So let's take a look at the data sheet. I have some of it already filled in. Plot 1, I'm not going to fill in the coordinates for the time being, but here is what that would look like, right? I had 6 trees. Here's their diameters. So if I had 6 trees and I had a basal area factor of 10, then I just take 10 times 6, and I get 60 square feet per acre. And then I had 24 trees in a 1/5 acre plot, so I just need to take 24 times 5. I get about 120. Let's see. And a chance to write any notes over here. So no nest trees observed. And maybe we make a note that says no feed trees observed. Okay, so let's scroll down. I'm getting all that goofy, but you get the idea. And this is grayed out because, right, it's one plot, and then we have these trees in that one plot, and then we only have one value per plot. Okay, so now we want to come in here and tally how many trees we had in each diameter class. So one in the 16 to 19, I had a 7.4 right there, an 8.6, so we'll put that there, another 7.4 there, 6.5, so put that here, and 13.8. All right, so that's the distribution of trees, and that comes in handy for this chart that we're going to show you here at the end. So I keep scrolling up. Now I've got my canopy cover, and I was telling you to use like 1s and 0s, and if you read the data sheet, it says to put a T or an S, but it's really the same thing. The idea is this would be like a 0 or an S, and then a 1 or a T. And this is kind of what that looked like. Now, why 1s versus T's? All right, the nice thing about 1-0 data is that when you go to use Excel, I can just do a sum at the bottom of this column and I know exactly how many hits I have. It's a little bit more complicated to do a count. You could easily go in and count the number of T's though, but you can quickly use mathematical data and averages and so forth if you're just using 1s and 0s. So that's why that is fairly helpful. I'm going to pause real quick and finish filling that out for you. Okay, so I have this filled out, the 1-0, the number of hits from the densitometer or the moose horn. But this down here is not a sum of this. Instead, it's that idea of how many trees have interlocking canopies within the plot, and you're measuring them from the end of that transect. So my first one, I had 6 trees with interlocking canopies, and then 4, 1, and 3. Okay, moving on down. Oh, the 3's coming with us. I don't know how that's the case. We'll just erase it. Now, I want to show you this Form 3. This is not a quantitative, it's more of an evaluative assessment. All right, so percent canopy cover of each plot, or I say that, but this first one is quantitative. So basically the number of total hits or ones divided by 45 times 100. So we're just getting the percentage of how many times we hit canopy. Okay, so I had 15 total hits that were, ones or trees divided by 45 options. And that gives me 0.33, and then I take that times 100 and I get 33%. All right, a little higher than I would have expected. How many number of interlocking canopy trees? And this part you could probably just do an average here. An average there is probably around 4. I could calculate that out, but I'm not going to. How many small clusters of even-aged trees? So an even-aged trees are trees of about the same size. I'd say we had about 2 clusters there. And do any trees within the clump seems like nest trees have a big diameter? And I would say no. And how many trees are greater than 25 inches dBH? I had 0. How many trees between 12 and 16 inches dBH? And that is what they say, having a high number of trees in that range is correlated with having a lot of squirrels. So let's just go back. So 12 to 16 inches. Let's go back up here. It looks like I had 2 trees in that size range. So we'll say 2. And do any of the trees seem to be feed trees? And we said no. So this then, if we were out in the field as a group, I would have taken this information from every group and put it into that Excel chart like I provided to you as example data. And then you can use that information as well. Well, primarily this information really, because this gives you the size classes and kind of the important habitat characteristics. And then you can compare it against these key things for each of their habitat components. So we have food. They want vigorous trees between 10 inches and 30 inches that gives them good food of inner bark. Presence of cone trees for the seasonal, that's more than 25 inches dBH. Patch of dense canopy, several of them. So maybe we had a couple of those. And so anyway, as you evaluate your data, compare it against these summations right here, because I kind of already have this all picked out for you. So you can kind of make some quick assessments of our plot just based on the summary of their habitat components. And that's it. That's kind of the end of the data sheet. That's what we would have done in the field. I just, right here, you can see the literature cited on what I based this lab off of and other research that's been done on it. All right, hopefully that makes sense.